All right, everybody, we are going to talk about or begin talking about section 9.2 today, and that is going to be dealing with angles and different types of measures. You're used to degree measure. I'm going to introduce you to something called radian measure, which we're going to be using the rest of the time we talk about in trig, and then we'll get into some applications with radian measure, and then coterminal and reference angles. That's everything that we're going to do in section 9.2. I have posted the PowerPoint that I've used in class before that goes through this entire lesson that we're going to be breaking up into 3 different days, but you're welcome to look at that PowerPoint and go through that and use it as a reference as well, because these notes are just kind of, they're just basic. So an angle itself, hopefully you know what an angle is. It's created with 2 rays. So it has, oh, sorry, that was bad. So let's use a different color. How about yellow? It has 2 rays here that pivot around one vertex. And that pivot, or those 2 rays, the ray on the x-axis, this one right here, that is called the initial side, because that is where it's going to begin. All of the angles that we talk about in this unit are going to have the vertex at the origin and the beginning ray lying on the positive x-axis. It's called the initial side. The other ray, so where it stops, is going to be called the terminal side. Just like if you go to the airport terminal, that's where you stop. Or if you're terminated, right? That's terminal, that's stopping point. Anything that's rotated counterclockwise, so the way the quadrants run, those are going to give us positive angle measures. So if it's following the way of the quadrants, that's positive. And if it goes the other way, if it's going clockwise, backwards, then that's going to give us a negative angle measure. One full rotation is 360 degrees. We know that that's a circle. So all the way around is going to be considered 360 degrees. So we need to know that in order to draw the sketch of an angle, it's really important that you start with not an arrow, and then you're going to rotate around as much as you can, and then the end has the arrow. So the arrow is at the end. Sorry. All right, so 75 degrees is going to be in the first quadrant, because we know each quadrant has 90 degrees. So maybe we should write that. So each quadrant is 90 degrees. So this would be 90, this would be 180, this is 270, starting at 0, and then all the way around would be 360. So you need to know those things as we go forward. So 75 wouldn't quite be to 90. So we start it at the origin, positive x-axis, and it rotates up because it's positive around the quadrants, but not quite to 90 degrees. Now, negative 160 is going to go the other direction. It's going to go clockwise. So this would be negative 90. This was negative 180. This would be negative 270 and negative 360 as we rotate the opposite direction. So negative 160 would come maybe to about here. Not quite going to get to the other side of the x-axis. And then lastly, 430 degrees, it is going to go in a positive rotation. However, it's going to go around more than once. That's bigger than 360. So we have to figure out how much that is. So if I just take away 360 here, oops, pen would be nice. Okay, so what will we get when we get past 360? And so we get about 70 degrees if we take that away. So 70 degrees is where we're going to land, but we have to go around one full turn. So we're going to go all the way around and then stop at 70 degrees. So you can see that we have couple different ways for us to show the types of rotation that we have. All right. Now, that probably should be some review for you. Today, we're also going to talk about something called radian measure. Now, a radian measure is just a unit of measure that's based on arc length instead of the rotation. So 360 degrees is one full rotation, and that is going to equate to 2 pi, right? So the arc length of a circle, the circumference, is 2 pi times the radius. So the arc length, the rotation there is just 2 pi, and that's how we get the radians. It's a full circle. So if 2 pi is a full circle, then only going halfway across to 180 degrees is half of that, so that's going to be pi. And I'm going to give you one more here. 90 degrees is going to equal 1/4 of that. So that's going to be just taking the 180 and dividing that by 2 again. So we're going to talk about these at length as we go through. You're going to get to know several different radian measures that you're going to need to memorize, but these three are pretty important. 360 is 2 pi, 180 is just pi, and 90 degrees is pi halves. We can convert any of these to between radians and degrees by using the conversion factor. We're going to use this one because it's the most simplistic. Pi is 180. So if I have to convert radians from degrees to radians, I take the degrees and I multiply it by pi over 180 because it's going to get rid of the degrees, right? 180 is the degrees. We get rid of that, and we'll just be left with radians. If I want to convert from radians to degrees, I take the radians, divide it by pi because that gets rid of the radians, and then I'm just left with the degrees part, so however many degrees. So this is just a conversion factor, just like feet to inches or 60 seconds in a minute, anything like that. This is just the conversion factor that we use. So let's see it in action. If I have 30 degrees and I want to convert it to radians, well, I need the degrees on the bottom so that I can get rid of them, and the radians are going to be on the top. So that's 180 degrees over pi radians. And so I'm going to be left with 30 pi over 180. Little trick, if you use your calculator, you put 30 divided by 180 in your calculator and hit math, enter, enter, and it will tell you that it's 1/6. So you can say 1/6 of pi or just pi over 6. So it will reduce that fraction for you. Try it out. Give it a try. See if you can do it. So let's do 150 degrees. So I would say 150 times pi over 180. And then I would reduce. So 15 over 18 is going to give me 5 over 6. So 5 over 6. And then make sure you use the pi. A lot of people will forget to put the pi in their answer because they've used their calculator, but the pi does need to be there. All right, now this one, there's no difference if the angle itself is negative. We're just going to have a negative answer. So again, we're going to get rid of the degrees, so the 180 needs to be on the bottom. And if I reduce that or hit math, enter, enter, I get negative 11 over 9. Don't forget your pi. So negative 11 pi over 9. Okay, now we're just going to invert that process. Instead of putting the 180 on the bottom, we're going to put the pi on the bottom so that we can get rid of it. What you're going to notice is, hey, the pi's cancel out. That's so nice. And so, oh, you can't see that very well. Let me. All right, here we go. So the pi is going to go away, and you'll do 4 times 180 and then put that over 3. So 4 times 180 is 720 divided by 3. And then we would again hit math, enter, enter, or just do that math problem and you get 240 degrees. Again, using our calculator to help us. And these are degrees because we're converting it to degrees. All right, if we are going to do the negative 5 pi over 6, we'll know the answer is going to be negative. We're going to multiply by 180 over pi. The pi goes away. We do 5 times 180, which is going to be, the whole thing's going to be negative 900. And then over 36, put that in our calculator, and the answer is just going to be negative 25 degrees. Last one, we're just going to take 7 pi over 4. We're going to multiply by 180 over pi. The pi's cancel. I do 7 times 180, which is 1260, divided by 4. Now you can do that in your calculator all at one time. 7 times 180 divided by 4. And it will tell you the answer is 315 degrees. Okay, that's all there is to it. Make sure you're doing some practice. There's a Delta Math practice. If you need any help, just let me know.